All right, so we are going to continue with the piecewise functions and continue with numbers 2 through 4. So if we take a look at number 2, here is our functions and the domain. So when we go through and do this, the first function is this with this domain. So we make our table of values. We start with -1 and we notate whether or not it's going to be opened or closed. And then we're just going to evaluate. So we're just going to plug in -1 plus 2, take the absolute value of that, which is going to be 1. And then 1 plus 1 is 2. So what we're going to have is an open dot at -1, 2. So -1, 2, open. -2 is going to be -2 plus 2 is 0. Absolute value of 0, 0 plus 1 is 1. Now we're going to plug in -3. So we got -3 plus 2 is -1, which gives us 1 plus 1 is 2. Remember, an absolute value is going to be a V shape. And then we've got -4 plus 2 is -2. The absolute value of -2 is 2. 2 plus 1 is 3. And you can see that the V is going from here and then on over. So I just make a little tick mark. You could do more points if you needed to, but it is just going to continue on in that direction. Then we notice that the Y is 3 when X is exactly -1. So that is actually just a point, -1, 3. It's not an equation because this is saying that X only is -1. If it gave you a different domain, then it would be a horizontal line. Now we have a linear equation at X is greater than -1. So we're going to plug in -1. So we've got -1/2 times -1 plus 5. So that's going to give us 1/2 plus 5 is 5.5. And it is going to be open. So when we do that, we're going to plot -1 and then 5.5 open. Remember, when you are done with all of these piecewise, it should pass the vertical line test because these are all functions. If I plug in 0, I'm going to get 5. And if I plug in 2, I'm picking multiples of the denominator so that I can get nice, pretty numbers. So 1/2 of 2 is 1. This gives me a -1 plus 5 is 4. So 0, 5, and then 2, 4. And then what I could do from here is utilize the slope down 1 over 2. So down 1 over 2, down 1 over 2, and continue that process until I am off of the grid. Okay, so that is what number 2 would look like, the domain. I'm going from -infinity. It looks like I stop at -1, but -1 is included, so I'm not stopping. Then I pick back up and go on to infinity. So the actual domain is all real numbers. The range. So the smallest Y value is going to be -infinity because this line keeps going. So I've got -infinity, and then it looks like I stop at like 5.5, but 5.5 exists on this line and it continues up. So our range is also all real numbers. Let's take a look at number 3. And again, what we want to do is organize our table according to the domain. So I've got from -4 to 0. The -4 is going to be closed, and then we just evaluate. So we've got the square root of the opposite of -4, and then we're going to add 3. So that square root of 4 is 2. 2 plus 3 is 5. So I've got the point -4, 5, and it's closed. Knowing that this is a radical, it's going to have some sort of a curve. So now we've got, and I'm just going to continue to do my algebra. The problem with this is that I've got the square root of 3 plus 3, so it's not a nice pretty number. So I'm just going to keep going and evaluating until I get something that kind of makes sense, and then I can just always estimate these values if I needed to. So here's going to give me 1 plus 3, which is 4. And then I've got 0 plus 3, which is 3. So if I were to make sense, I'm going to plot this one and then these two. So -1, 4. And then 0, 3. The 0 is not equal to, so this one is going to be an open circle. So 0, 3 gets here, and it stops just right here. It does not go on forever because it's needed to stop at -4, when x is -4. When y is 2, x is 0, which indicates, again, another point at 0, 2. And then now I have got rad x plus 3, 0. This is going to be open. So the square root of 0 plus 3 is going to be 3. Square root of 1 plus 3 is going to be 4. Again, this is going to be 3 plus rad 2, rad 3 plus 3. We'll have to approximate that, or I can just plug this in. I get 2 plus 3, which is 5. So if I were to plot those points, 0, 3, again, is an open. Then I've got the point 1, 4 from my table. And then I've got the point 4, 5 from my table. Notice that this keeps going on. So the next thing I could do is just put in 9. The square root of 9 is 3 plus 3, which is going to give me 6. So I could go 9 and then 6. And then I have enough to continue like that. The domain is going to include -4. It still includes 0 because of this point, and then it goes on to infinity. Range. Notice that the y value here is 2, and it's all by itself. So that's the 2. I've got a union symbol. Picks back up at 3, but doesn't include the 3, and then goes on to infinity. So now let's take a look at number 4. Again, we're going to look at this as a table. X is less than -2. So if I were to plug in the opposite of -2 minus 2, that's going to give me 2. Minus 2 is 0. 0 plus 2 is 2. So I've got -2, 2, and this is going to be open. -2, 2 is open. Now let's plug in -3. This gives me 3 minus 2 is 1. Square root of 1 is 1. Plus 2 is 3. So I've got the point -3, 3. And then something unique happens here. This gives me 4 minus 2, which is rad 2 plus 2, which means I kind of have to approximate it. So what would make sense would be for me to try and get nice numbers where I can get nice integers for my outcome. So you want to be able to think about your perfect square. So basically, I wanted to be able to figure out if I were to go -x minus 2. So what number for x is going to give me a perfect square? So I would just set the inside equal to whatever I want it to get. Well, I want it to be a 1. And so that's going to end up giving me that -3. So what I'm going to do is want to get a 9. So that means I'm going to solve for x. When I add 2, I get 11. Divide by a negative, so I'm going to get negative 11. So if I were to plug in negative 11 right here, I'm going to have the opposite of negative 11 minus 2. So 11 minus 2 is 9. The square root of 9 is 3. 3 plus 2 is 5. So negative 11 plus 5, or I'm sorry, negative 11, 5 would be right here. And all I'm going to do is connect them and make an arrow. For the line, we know that the line is going to go from negative 2 to 1. This is going to be an open, and this is going to be an open. I purposely left off the values. You can always use a table, or you can utilize the slope. So if I were to plug this in, negative 2 times negative 2, that's 4. 4 minus 2 is 2. So I have the point negative 2, 2. So negative 2, 2. And it's open. So again, I have this open circle right here. And now I want to do a line, and I finish it at 1. So negative 2 times 1 minus 2. That's going to give me negative 2 minus 2 is negative 4. So 1, negative 4. And again, that's going to be open. And remember, I'm connecting this through a line. So I can make just a line, or I can also utilize the slope down 2 over 1, down 2 over 1 to make sure I'm connecting them with a line. And then the last equation here is another square root. So if I start at 1, again, this is going to be open. The square root of 1 minus 1 is 0. 0 minus 4 is going to be negative 4. Then let's go ahead and plug in 2. So I've got this. I've got 2 minus 1 minus 4. This gives me a 1. This is going to give me a negative 1. Minus 4 is negative 5. So 2, negative 5. If I do a 3, the 3 is going to give me a rad 2. So really what I want to do is think, what could I do in order to get a 9? All right. Or even a 4. So that means if I could add 1, that means my x would be a 5. So if I were to plug a 5 in here, 5 minus 1 is going to be a 4. So I get, this gives me a 2 ultimately. So negative 2 minus 4 is negative 6. So I have the 0.5, negative 6. It's a little messy here. And let's try and figure out what I need to do in order to get a 9. My x would have to be a 10. So if I were to plug in 10 minus 1, that gives me 9. This gives me the square root of 9 is 3. So negative 3 minus 4 is going to be a negative 7. So 10, negative 7. And then all I need to do now is just connect it, and it goes on. Let's take a look at the domain. Starts at negative infinity, goes to negative 2, does not include negative 2, picks back up on the other side of negative 2 and goes to 1, doesn't include the 1, then it picks back up on the other side of 1 and goes to infinity. Okay, now range. The very smallest y value is negative infinity. The next y value where there's a break is at negative 4. It doesn't include the y value of negative 4. Picks back up on the other side, goes to a y value of 2. Picks back up and continues on from 2 to infinity.